Hello, welcome to ANS Solver. This is the fifth question of the paper. So they have given us that the number of eagles seen per hour, okay, in a certain location has a Poisson with the lambda 1.8, okay. The number of vultures seen per hour, so this was eagles, these are vultures, seen per hour in the same location have a Poisson with the lambda 2.6. So find the probability that in a randomly chosen hour, at least two eagles are seen. So we need the probability of x being more than equal to 2 because at least suggests that it's more than equal to 2. And we only need eagles and in 1 hour. So I know my lambda is simply 1.8, which we have here. So now to calculate the probability of x more than equal to 2, I can write this as 1 minus the probability of x less than equal to 1, which can be written as 1 minus the probability of x equals to 0 plus the probability of x equals to 1. Okay, now I know my Poisson formula, simple formula is basically e raised to minus lambda into lambda raised to x over x factorial. Got it? So now I can write this as 1 minus e raised to minus lambda, which is 1.8, into 1.8 raised to 0 over 0 factorial plus e raised to minus 1.8 into 1.8 raised to 1 over 1 factorial. So I can simply solve this on the calci. So I can write this as 1 minus, okay, so just solve this on the calci, e raised to minus 1.8 plus e raised to minus 1.8 into 1.8 raised to 1 over 1 factorial. Okay, so yeah, just 1 second, I'm just the calci, yeah, this is what I can write. So I get my answer here as 0.4628. So now I need to do 1 minus that. So I'll get my answer as 0.537, which is the final answer of the question. Now, find the probability that in a randomly chosen half-hour period, okay, half-hour period, the total number of eagles and vultures seen is less than 5. Okay, so first thing I know that the lambda of eagles in a 1 hour period, okay, in 1 hour I know, okay, is 1.8, correct, and the vultures I know in a 1 hour period is 2.6, correct. Now what I need to do is they have given me a half hour period, so the half hour period means 0.5 hours, so 0.5 into 1.8, okay, can simply give me 0.9, and here also 0.5 into 2.6 can give me 1.3. Now because we need the total number, my final lambda will be equal to lambda 1 or lambda of eagles plus the lambda of vultures, which will be equal to 0.9 plus 1.3, okay, so it's simply 2.2. Got it? So now what we need to do is we need to calculate the probability that x is less than 5, which can be written as probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2 plus the probability of x equals to 3 plus the probability of x equals to 4. Okay, because it's less than 5, So now I can write this basically as, I know my formula, I'll write it again. It's e raised to minus lambda into lambda raised to x over x factorial. Got it? So now I can write this as e raised to minus lambda, which is minus 2.2, plus e raised to minus 2.2 into 2.2 raised to 1 over 1 factorial, plus e raised to minus 2.2 into 2.2 raised to 2 over 2 factorial, plus e raised to minus 2.2 into 2.2 raised to 3 over 3 factorial, plus e raised to minus 2.2 into 2.2 raised to 4 over 4 factorial. Now see, you have written all the steps till here. Now, you can sit and solve this full thing on the calc, you can write everything. But I can give you a simpler method. So on the calculator, what you simply do is click on shift and click on the log button, which looks something like this. So on your display, you get something like this. Got it? So now, what I put in the calc, we are basically calculating the summation because of the plus. We are calculating the summation from 0 to 4. So here I write 0 and here I'll write 4. Now in the calc, in the bracket, I'll write e raised to minus 2.2 because my lambda stays constant into 2.2 raised to x over x factorial. So x basically will take all the values from 0 to 4 inclusive. And how do I write x on the calc? Just click on alpha and the closing bracket sign. Okay. So when you do that, so just plug this in the calc. Even I'm doing it. Yeah. And now when you plug this in and click on equal to, you get the answer as 0.928, which is basically the final answer of the question. So very important, you need to write all your steps till this, okay? But then after that, you can use your calc because it's basically a faster method. Now, Alex wants to be at least 99%, okay? So at least 99% certain of seeing at least one eagle. Find the minimum time for which she should watch for eagles. So in 1 hour, my lambda for eagles I know is 1.8, correct? Which we got here in 1 hour. So now they are asking us to calculate the time. So we can take the time as t hours. So my lambda will be 1.8 t, correct? Now I need the probability of exactly or at least seeing one eagle to be at least 99% means 0.99. Correct? This is what I need because at least suggests the crocodile sign, something like this. Correct? More than equal to. So now I can say x more than the probability of x being more than equal to can be written as 1 minus the probability of x equals to 0, which is more than 0.99. And I know my formula is simply e raised to minus lambda into lambda raised to x over x factorial. So using this formula, I can write this as e raised to minus, I know my lambda is 1.8t into 1.8 raised to t, okay, not raised to, sorry, into 1.8 t raised to 0 over 0 factorial, which will basically just give me e raised to minus 1.8t. So I can write this as, I'll just make a line here. 1 minus e raised to minus 1.8t, which is more than equal to 0.99. So this can basically be written as 1 minus 0.99, which is more than equal to e raised to minus 1.8t. So I can write this as e raised to minus 1.8t, which is less than equal to, okay, 1 minus 0.99, which will give me 0.01. So now what I simply need to do is I need to calculate t. So because there's an e, I'll do ln on both sides, basic logs. This is what I'll use. Now I know a log property which suggests that the log of a raised to b can be written as b log a. So using this log property, I can write this as minus 1.8t ln e is less than equal to, if you do ln 0.01 on the calci, I get minus 4.60517. And I know ln e is basically 1. So this is 1.8t, which is less than equal to minus 4.60517. So I can simply, now I can multiply negative to both the sides of the equation. So I'll get 1.8t here and I'll get 4.60517. But in inequalities, when you multiply negative in both the sides, the sign changes. So here I'll get t, which is more than equal to 4.60517 over 1.8, which will give me my t, which is more than equal to, you can solve this on the calci. So I get my answer as 2.56, which is basically the final answer of my question.